Precalculus Iii, vectors. And we're going to be learning vector visualization, component operations, the dot product, and orthogonal vectors. Let's start off by vector visualization. So let's say we have vector v, and let's say we have to add it to vector u, right? Without knowing the components, the addition of the vectors would basically be vector v, vector u, and the addition would be this space right here. Basically, the space, like the thing connecting this to this point, would be the solution of the addition of the two vectors, and this is referred to as the triangular method. And if a vector starts off at this point at 0, 0, then it's a unit vector. And the components of a unit vector, let's say this is 1, 2, 3, 1, 2, 3, 4. So basically, let's say this is vector n. So the components of vector n would be 3, 4. So vector n, and then we express this in these fancy brackets, 3, 4. And it's basically what a component is, like component. So we can also add vectors this way. So we can say vector v is equivalent to, let's say, -4, 1. Let's just go through a whole bunch of operations with these two vectors. Let's do n plus v. Let's do n vector n minus vector v. Let's do vector n multiplied by vector v. And let's also do vector n dot vector v, which is basically the dot product, which we'll learn about when we get to it. But let's talk about addition of vectors. So the addition of vectors is basically like regular. You add a and b, you add the c and d, so you add a, b. So we add a and c, and we add b and d, and we get a vector like that. So the additions would be 3 plus 3 plus minus 4, which would be 3 minus 4, which would be -1. This would be 4 minus 4 plus 1, which would be 5. And that would be the addition of vector n plus vector v. Vector n minus vector v would probably be 3 plus 4 would be 7. And 4 minus 1 would be 3. Now vector multiplication, n times v, that will basically be -12 and 4. Now let's talk about the dot product really fast. So the dot product is basically like, so let's express n and v as components, right? But actually, before, let me just give you like the formula of what a dot product actually is. So let's say we have two vectors, a, b, c, d, right? Let's say we have that. And let's say we had to dot them. So the dot of these two vectors would be AC plus BD. Basically, this is the dot product. So let's express n as 3, 4, dot -4, 1. And now we have to take the dot product, which would be -12 plus 4, which would be -8, would be the dot product. Okay, so we just learned component operations. Now let's go more in depth to the dot product and what that is actually. So before that, let's learn some vocabulary. The magnitude of a vector is basically symbolized by these like absolute value thing. So the magnitude of a vector is basically the vector's length, and it's equal to square root of a squared plus b squared, given that vector v is ab. And yeah, it's basically what a magnitude is. And something interesting, vector u dot vector v is also equivalent to the magnitude of vector u multiplied by the magnitude of vector v times the cosine of theta. And theta, okay, I haven't gone over what theta is, but for vectors, theta is like the angle caused by them, so, and this is basically theta, the angle caused by the intersections of the vectors. So another interesting thing about the dot product is that the cosine of theta is equivalent to vector u is that multiplied, okay, vector u dot vector v over the magnitude of u multiplied by the magnitude of v. So another interesting fact, we basically just, it's a variation of the formula. And yeah, it's kind of some dot product stuff. And now let's before we get into our orthogonal vectors, I think I forgot to talk about something, and it's basically speed. Stuff you need to know for like this unit where we're gonna have word problems. You might see word problems on a test often. So you're gonna need to know speed is equal to distance over time. That's pretty important. And you're also gonna want to know velocity is equal to displacement over time. So basically, yeah, that's something you're going to need to know for the word problems we're about to complete. Now let's talk about orthogonal vectors. So basically, if vector u dot vector v is equivalent to 0, then the vectors are orthogonal. And basically that means they're perpendicular. So yeah, that's about it. Now let's get into the practice. So let me erase this. So yeah, I think vectors, they look kind of scary when you like look at them, but they're pretty simple. I mean, like the brackets look really fancy. But okay. Before we solve these problems, make sure we know all the formulas. The cosine of theta, or let me not write, I shouldn't write here. The cosine of theta is equivalent to u dot v over magnitude of u over magnitude of v. We also have AB dot CD is equal to AC plus BD. Okay, let's get into word problems now. Oh yeah, I forgot the speed is equal to distance over time, and velocity is equal to displacement over time. Okay, let's get to the word problems now. I like the problems. Yeah, the first one is actually a word problem. Let's go write it down. Okay, so the problem is a plane is flying. A plane is flying east at 70 miles per hour, and 40. Okay, there is a wind there is a wind at 40 miles per hour north. Find the plane's pathway with the wind. Okay. So let's do some labeling here, okay? Let's say vector v is equal to plane flying east at 70, plane flying east at, oh yeah, something I also forgot to say, a magnitude of something is equal to square root of a squared plus b squared. Actually, I think I said that, but whatever, useful to 10, okay. So the magnitude of vector v, vector v is equal to plane at 70 miles per hour, right? And we can say vector u is equivalent to wind at 40 miles per hour. Okay, so we know which direction east is, so vector v is basically at 70, and then it goes north for about 40. So north for about 40, and it's vector u. And then if something should jump out at you, it's that this is a right triangle. They're orthogonal. That means that we just have to use the Pythagorean theorem to figure out what this side is, the solution. So let's do x squared is equal to 70 squared plus 40 squared. X is equal to square root of 70 squared plus 40 squared. And that's basically the answer. I don't exactly have a calculator on me, but that would basically be x. Now let's try finding the dot product of three-dimensional vectors. So three-dimensional vectors are basically vectors containing three like components, A, B, and C, like that. And basically, like, we don't have to visualize them for pre-calc, but they're three-dimensional, something cool. So let's say we have to find the dot product. Let's say we have to find the dot product of vector v. Vector v is equivalent to 941. Vector u is equivalent to 600. Let's say we have to figure the dot product of vector v dot vector u. That would basically be AB, which would be 54. CB, or AC, BD, which would be 0. And EF, which would also be 0, which would be 54. So the dot product would be 54. Okay. Let's do the final problem, I think. Okay, let's do, there's a really fun one to do up next, but I'm gonna do the, like, not the boring one, but the kind of less stimulating one first, to leave the fun one for the end. Let's do 5, 4, dot 3, 1. So again, that's kind of simple. That's 15 plus 4, and 15 plus 4, which would be 19. Okay. So I was thinking about something else there. Okay. Now let's do the fun one. Or we don't have to really erase anything here. I don't exactly know what I'm doing. Okay. So now we have to figure out, okay, the next problem, let me write it down in blue because it's like, it's an actual problem. Find v given, find vector v given the initial point, given the initial point 2 is a -2, and -2, 3, and -5, and given the final point negative 1. I think that's a 9, negative 1, 9, 2. Okay. So, how would we do this? How would we do this, right? So basically, if you're not aware how vectors like are classified, like if a vector starts off like a vector is classified by like its endpoint or like the arrow. So let's say this is a vector. The point right here would basically classify the vector. Like we can say if the point was like 2, 4 or something, then we could say this was vector like whatever. I'm tired of using v. The vector could be about equivalent to 4, and that's how we would define a vector. So, but here's the thing: it does not start at 0, 0. It does not start at good point to measure at. So let's think a minute. We're basically given a vector. Basically, it's a 3D vector. But I'm illustrating a 2D space just to make sense. We're basically given a vector over here, right? And we're asked to figure out how do we define it, right? So we have the initial point, right? And we have the final point. So to figure out the vectors like points overall, we can just assume that this point is the origin. We can assume that this is a unit vector. And we can have this subtracted. We can have this subtracted by this to get vector v basically. So we have to do negative 1, 9, 2, minus negative 2, 3, negative 5. Okay. So negative 1 plus 2 would be 1. 9 minus 3 would be 6. And 2 plus 5 would be 7. Okay, so that's basically vector v. We did all the practice. Expect Precalc 4 to come out tomorrow, even though no one watches this on matrices. Thank you for watching.